Section 3A. What does that mean? That means there's a 3B because they're going to use this as a part of other problems. So far, we have not been able to square root negatives, and I've been telling you, hey, that's no solution, but that's not really the case. If we were to square root a negative number, it doesn't produce any real results. Actually, it produces something called an imaginary result. Square rooting a negative isn't a real number because nothing times by itself will equal a negative. The only way to get to a negative is a positive. Let me make sure I'm, A positive times a negative is the only way to get to a negative, so it's got to be something other. It doesn't exist. Only a negative times a negative is equal to a positive, or a positive times a positive is a positive, and nothing times itself will equal a negative, so they had to come up with an imaginary unit. What they decided is that they said, well, what if we made square root of negative 1 as the imaginary unit I, and then we define it as it's the thing that when you square it, when you square I, it becomes negative 1. It's an imaginary unit because a positive times a negative equals a negative. There's no way to get something times itself equals a negative. We're going to just define it this way. So literally, if you memorize these two things, you're going to be able to do a lot of the problems on this worksheet. I is the square root of negative 1. We're going to be turning these things into i's, and then we're going to be turning I squareds into negative 1. The basic idea behind this is that we're going to have real parts of numbers being added with or subtracted by imaginary ones. That's what a complex number is. As a matter of fact, some of our calculators even do complex numbers. The 300 model, which is my numbers 1 through 15 calculators back there, those do not do complex numbers. But numbers 16 through 35, the gray calculators, those ones actually have a complex number setting. In case you're interested in that, look for it. Go under mode and turn complex numbers on, and that will change what the calculator is able to do. But the 300 model cannot do that, just so you know. For example, I have a 300 calculator here. I want you to see this. If I actually turn my 300 calculator on, I type in the square root of a negative 16, my calculator is going to tell me error. You know why? Because it cannot produce something times itself equals a negative. It's not able to do the square root of a negative number. So how do we do it? What we're going to do is we're going to turn this into the square root of 16 times the square root of negative 1. That will be the same thing as that. And we can simplify this. This is the same thing as I. And I know what the square root of 16 is. It's 4. So our answer for something like this is going to be 4i. That's it. I is just going to represent the square root of negative 1, and it's going to be a part of our answer. Some of you will need to break it apart into two pieces at first, but others of you, if you see a negative, a square root of a negative, I just like to go like this and go, okay, that's going to be I. What's the square root of 16? It's 4i, and then I cross it off, and that's my answer. Goes pretty quick. Always start with the negative before dealing with any negative, any exponents if it comes to it. By the way, if you have a 4i and another 2i, you can add those together and get 6i. 4 imaginary i's plus 2 imaginary i's is 6 imaginary i's. That's how it works. It's the same thing. But if I try to do 6i plus 1, guess what? That's 6i plus 1. I just didn't write it in standard form. Standard form would be the real part first, the imaginary part second. The last thing I'm going to show you before we get into examples are how this stuff simplifies. If you have I to the first is just I squared we said is -1, but what about I to the third power? If you think about I to the third, isn't that I squared times I? And don't I already know what I squared is going to simplify to? Isn't I squared -1 times I? Well, what is -1 times I? It's going to be -I. That's what I to the third simplifies to. What about I to the fourth? It simplifies, doesn't it? Isn't that the same thing as I squared times I squared? I know what I squared is. It's -1, and I know that I squared is -1. What is -1 times -1? That's what that simplifies to. So as you do the problems on the back side of this worksheet, the bigger the exponent, the more you're going to need to break it down into either I squared or I to the first to figure out what it's going to be. So let's do some problems. I can't square root -36. I have to use the imaginary letter I, but as soon as I do that, what is the square root of 36? If you need to break it down, break it down. But my final answer is 6i. It's not hard. I hope it's not hard. The hard ones become, how do I write my final answer? So if you have something like number 9, I want to show this to you. If you have an I outside, and you have a root 27, and you do the 3 times 9 and 3 times 3, sometimes a number will pop out, and there'll be something left inside. So then we go numbers, then letters, then radicals. Why do I say that? Because my final answer would be 3i root 3. It's a funky answer, but there you go. The 3 pops out, the number, then the letter, and then the root 3 is inside the radical. Number 12. Sometimes they're going to ask you to combine like terms. If there's an addition sign, means you're taking this and you're adding the product to that. Well, there's nothing in front of these parentheses, so we don't need them. But there's something in front of these parentheses, so we have to multiply before we can drop them. 24 minus 16i. Once you've multiplied, you don't need the parentheses, and now you can put your real components together. This can be added with that because they're both real numbers. 8 plus 24 is 32. Now let's put the imaginary components together. 3i minus 16i is negative 13i. And then that is in standard form, a real plus the imaginary component. A lot of people find number 12, 10 through 15 easy. Where does it get harder? When you multiply. When you multiply, things get a little bit tougher because you have to remember what I squared is. When you're multiplying, you can multiply in any order, so I would multiply 2 times 5, and then multiply that times the 8. You have 3 i's multiplying, which is I times I, which is the same thing as I squared times I. We've already talked about that. What is I squared? Doesn't that simplify? What is I squared? I squared is -1. So we have to take that 80 and multiply it by negative 1, multiply it by I. So my final answer would be negative 80I. What I like about I squared is that it just changes the sign of whatever it multiplies by. I have 2 more examples and then we'll be done. They want you to look at a product, binomial times a binomial with imaginary numbers. They even put it in the area model just so you could see it. You could do it this way, or you can do it this way. Doesn't matter. 1 times 4 is 4. 1 times negative 2i is negative 2i. 4 times 5i is plus 20i. And then this last box, this is where it gets complex. Get it? Complex numbers. This is where it never mind. Gets complex. It gets really complicated. This times that positive times a negative is a negative 10, and the I times the I is I squared. This will simplify. Negative 10I squared. I squared, it turns into negative 1, but you're multiplying by it, which means you're going to change this sign. It's going to turn it into plus 10. If you need me to work it out, it becomes that. Which means now this piece can combine with this piece. The 4 and the 10 can combine together because those are your real components. 14. Your imaginary components are next. Negative 2i plus 20i is plus 18i, which is your final answer. So unlike trinomials or binomials that come into a trinomial squared, because of these squared terms combine, you have a binomial as the answer. It's kind of neat. The last one that I have for you is 22. And that's because they give it to you like this, and you have to remember it's a binomial times a binomial, so you have to FOIL this out. 16 plus 32i plus another 32i plus a 64i squared. Now these two ones in the middle will go together, which is 64i, but something happens with this plus 64i squared. I squared turns into negative 1. 64 times negative 1 makes negative 64. So what I usually will do is I'll go over here and put the negative 64 with that 16. 16 minus 64 on my calculator is negative 48. And there is my final answer. I'm going to stop your notes right there.